Hi everyone, I hope everyone is doing well. I'm making this video to do a review of exam 3. This is the exam that y'all took before spring break. I'm going to be going over version A, so just keep that in mind as I'm going through the questions, and I'm going to go ahead and get started. So number 1, it's talking about a grandparent and grand offspring pairs of individuals in the absence of additional passive relatedness, so we're saying that these animals are not inbred. The only time you share the same exact amount of DNA is when it's a parent-offspring relationship, and this is not a parent-offspring relationship. So you can actually cross out these two answers. If we are doing X, Y, Z, this is not an example of common ancestry. And in the way that we did it, we'd count how many pathways. So we'd do a half and then squared because there's two pathways. So we'd estimate a quarter. So that's an estimation. But if you think about it, X gives Y half of its genes. And we know that for sure because it's a parent-offspring relationship. And it is possible that Y gives that exact same half that X gave. So it is possible for them to share half of their genes if Y gives Z the same exact stuff that X gave Y. But it also could be that Y gives nothing similar or nothing that X gave him to Z. So that explains the 0. And it could be a half if Y gives Z the exact same genetic material that X gave Y. They cannot be identical. Identical would be a relationship of 1, and they cannot be identical. So that is why the answer is not C. Moving on to number 2, a Tobiano paint. So this is coming exactly from y'all's horse color handout in the back where it goes over the different paint colors. Tobianos do have minimal white on the face. The transition between white and color is smooth, unlike some Overo patterns, the Sabino Overo. They have a lot of white on their legs. That's what makes them a Tobiano. White does cross the top line, normally somewhere between the ears and the tail. And as we did all of our questions, it is linked to the extension. We didn't work any examples with Roning or Sabino, but we did say that Tobiano is also linked to those. So that is correct as well. So the incorrect answer is C. Moving on to number 3, production system complementarity. If we think back to production system complementarity, we're wanting to use one set of characteristics in the dams that breed is strong for, whether that be reproduction and productivity, efficiency, and then we want a different set of sires that are stronger in a different set of traits such as growth and carcasses. So if you look at A and B, the dams that we're using are not necessarily, while yes, they can be very efficient and produce a lot of good calves, they're not necessarily what we think of our very maternal breeds, especially Charolais. We think of those as more of a sire breed to emphasize growth and carcass traits. Plus, we're using crossbred bulls, and if you think back, we get a lot of heterosis when we use crossbred dams, so A and B are not the best choice. However, C, the correct choice, we have our Angus Brahman cows. An Angus Brahman cross, it's very maternal, they're very efficient and productive, with a Hereford bull, which introduces a lot of growth and carcass characteristics. So C is the correct answer. Holstein cows, we would not be having very productive or reproductive efficient cows. We'd have a lot of milk, but that's not necessarily something that we think as complementarity. And then same with Holstein bulls to Jersey cows. So the correct answer for number 3 is C. Moving on to number 4, we have G and H that are half siblings that share sire S, and sire S inbreeding coefficient is greater than 0. So we know that S is inbred. Okay, so this is what our little pedigree is going to look like. They are half sibs, so they have different mothers. So if we just calculate it based upon looking at that, we know that our covariance, and if there was no inbreeding, would be half is a quarter, but we know that there is inbreeding. So we know that it is not equal to 0.25 or 0.5 or 1. But then if we consider that S is inbred, we have an increase in homozygosity. And when we have that increase in homozygosity, S is more likely to pass on the same allele to each one of his offspring because it is inbred. So he's more likely to give the same allele to G and the same allele to H. So that would increase their relationship coefficient. So the correct answer is A. For number 5, maternal heterosis for a character, blank contribution of a blank female to her blank progeny. On mine, I have 2 of the favorable purebreds. These right here. I'm pretty sure one of y'all's we changed to detrimental. We know that heterosis for a character oftentimes, most of the time, is not detrimental. So we can go ahead and cross out the 2 answers that are detrimental. And then when we're talking about heterosis, obviously we're talking about crossbreeding. So we're not going to be talking about purebred individuals. And so basically that cancels out all the answers except for D. And if we say that the dam is crossbred, then the offspring will also be crossbred. So it turns out being maternal heterosis for a character. It's the favorable contribution of a crossbred female to her crossbred progeny. Number 6, the dilution locus in swine. So if we remember the dilution locus in swine, we have big D, which gives white. Given that the other loci allow it, big D, which gives sandy. And little d, which gives red. So we can look, dominance is definitely not the genetic action because we do have an intermediate. And so it is, yes, it's the intermediate of phenotype of heterozygotes, but we have to consider the other loci, so it's not going to be that one. Phenotype of big D is closer to big D than the little g. That is not correct. It's intermediate, so it's not closer to one to the other. And if we think back, in order for us to see any of these colors at the extension locus, we must see little e. So it is the intermediate phenotype of heterozygotes on the extension locus. And we're talking about the dilution locus. So we are technically diluting the red color. So we're diluting it to sandy and then to white. And in order to see this intermediate sandy, we must have little e. So the correct answer for 6 is C. 7, Wright's relationship coefficient resembles which of the following statistics? So if we write out our relationship coefficient, the covariance of x and y, 1 plus f of x times 1 plus f of y. The correct answer here is the correlation coefficient, which is on the next page. And if y'all remember what a correlation coefficient is, it's actually the covariance between 2 things over the square root of sigma squared x times sigma squared y. So you can definitely see the similarities in the 2 equations. So the correct answer here is C.